In this video, we're going to tackle the definition of the degrees of unsaturation of a hydrocarbon molecule. Our learning goals will include how we determine that simply from a molecular formula, although I will say you can also determine it by looking at a structural formula of the molecule. So saturated hydrocarbons, what do we mean when something is saturated? Well, it really means that this molecule cannot add any more hydrogen atoms. In other words, the carbons have all single bonds attached to them and they're all filled up with other substituents. So we can't break a double bond and create two new positions for hydrogen bonds, for example, out of that. The degree of unsaturation basically is a measure of how unsaturated a molecule might be. Now remember that the typical formula for alkanes is going to be, if it has N carbon atoms, it's going to have 2N plus 2 hydrogen atoms. So N is the number of carbon atoms, and every degree of unsaturation means 2 fewer hydrogen atoms can be attached. So we might use this then to take a formula like C3H4, for example, and determine what the degree of unsaturation would be for that molecule. All right, so how does that work? Well, what we want to do is we want to compare this formula with the molecule that C3 would ordinarily create if it were fully saturated. Okay, that would have 2N plus 2, 2 times 3 plus 2, or 8 hydrogen atoms, and then find out how many fewer hydrogen atoms there are on this molecule, and then that tells us how many degrees of unsaturation there are. So, for example, in this case, there are 8 hydrogens possible, 2 times 3 plus 2. That means we're missing 4 hydrogens from the saturated molecule, and since 2 hydrogens represent each degree of unsaturation, we take that 4 and divide it by 2, so we have 2 degrees of unsaturation based on the molecular formula C3H4. Now, this is leading us into the realm of alkenes and alkynes, something that we'll talk about a little bit more in Module 7. But let's go ahead and tackle their definition now. Alkene is a hydrocarbon that has at least one double bond between carbon atoms. An alkyne has at least one triple bond between carbon atoms. So the simplest examples, that is the ones with only 2 carbons, include ethylene, which is C2H4, and acetylene, which is C2H2. So what would be the degrees of unsaturation for each of these? Well, first we'd say that the saturated version that has 2 carbons would be C2H6. So when we look at ethylene, 6 minus 4 means it's missing 2 hydrogens to become fully saturated, and 2 divided by 2 is 1, so it has a single degree of unsaturation. All right, each double bond in a molecule represents 1 degree of unsaturation. In the case of acetylene, we would find that similarly it has 2 degrees of unsaturation because it has a triple bond and it has 2 pi bonds. So this gives us a ready-made formula for either using the molecular formula to determine the degrees of unsaturation or simply looking at how many double bonds or triple bonds there are in the molecule. So why is this important? Well, you may have heard of talk about saturated and unsaturated fats in our diet. So saturated fats are ones that have no carbon-carbon double bonds. Now, you may notice that there is a carbon-oxygen double bond, but we're really focusing on the hydrocarbon part of palmitic acid to say that it is a saturated fatty acid. Unsaturated fats have at least one double bond in them. So for example, oleic acid or linoleic acid have double bonds in them. And you'll notice that these are not long straight molecules. Okay, this is a key to why they are less harmful to us, for example, than saturated fats, because they have different chemical properties. The saturated fats tend to form solids at room temperature, whereas the unsaturated fats are more likely to be liquids. So be that as it may, these have different health consequences, and it's all due to their molecular shape and formula due to the degree of unsaturation in them. So as an activity to illustrate this, what I want you to do is to look at this picture of beta carotene, which is also something that's essential in our diet, helps us make retinal, which we use to see, and determine what its degree of unsaturation is. Now I want you to base this first on a molecular formula, and then you might do it by counting up the double bonds. So pause the video and try this out. All right, have you gotten a degree of unsaturation yet? Okay, now I also asked you to think about why this is different using the formula is different from counting up the number of pi bonds. Well, if we use the formula, we should have a C40H82. 82 minus 56 is 26, which gives us 13 degrees of unsaturation. But if I go through and count up the double bonds, I would find there's only 11 of them in this molecule. So why the difference? Why are there different results for degrees of unsaturation? Well, it turns out that when carbon forms a ring, it also is a degree of unsaturation. So I have two ring structures on this molecule, and those represent the other 2 degrees of unsaturation. I hope this has made sense and that you'll be able to now figure out the degrees of unsaturation for any molecule based on either its formula or its molecular structure.